So for this one, I'm going to draw out a circuit. We have a cell and a resistor, and this cell has some internal resistance, and we're trying to see how the current and the potential difference will change as the internal resistance increases. So cell with internal resistance is all of this, and then here is our external resistor. Okay, so if we are to increase the internal resistance, which I'll call lowercase r, then the total resistance increases. So these two things are in series. The internal and the external resistor are in series. So if we increase one of them, we increase the total resistance in the circuit, as the total resistance is just the sum of these two things. So if we increase the total resistance by increasing the internal resistance, we will decrease the current, because the current is equal to the EMF divided by capital R plus lowercase r, which is the total resistance. And that's just a rearrangement of the equation V is equal to IR. So if our resistance increases, our current will decrease. So it's either going to be A or B. And our terminal potential difference, which is, well, we can look at that in a few ways. It's either the voltage across the external components. That's one way we can look at it. And another way we can look at it is the voltage across the cell when you have some kind of external component attached. That's another way that you can view it. I think the former in this case is probably better, the voltage across the external resistor. So if the internal resistance increases, again, there's a few ways you can look at this. One way is that if we know that our current is decreasing, then using the equation V is equal to IR again, because the current is the same throughout the circuit as it's a series circuit, then if the current goes down, the voltage in this component will also go down from V is equal to IR. This resistance, remember, stays constant, it doesn't change. So that means that the terminal PD will decrease. So then it's either going to be this or this, so we can see our option is therefore A. Another way that you can look at this is if the internal resistance increases, then it will get a greater share of the EMF, and the external resistance will get a lower share of the EMF. As when you have resistors in series, voltage splits in the same ratio as resistance. So whatever the ratio of these two resistances would be is how the EMF would split. So then if this resistance goes up, then this resistance, it can stay the same, but the voltage that it gets will decrease, as it now has a lower share of the total resistance.